So today we're going to cover section 5 of chapter 6. Today we're going to talk about inequalities in one triangle. Now, for those of you who are reading through your textbook using your Big Ideas app, in section 5, it also talks about indirect proof. We will not cover indirect proof, but if you're interested in learning about it, you can read through it in your textbook. I already understand that proofs are a challenging topic as it is. Then to talk about indirect proof, where you sort of have to think backwards, it gets even more confusing. So we will not cover it. Generally, it does not show up on a standardized test. So all we're going to talk about are the inequalities here. And we're going to cover 3 theorems, and then we're going to do some examples. So the first one, and again, these first 2 are common sense. So again, do not memorize the number. The first one is called the triangle longer side theorem. And what this states that if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. So for example here, what all that means is that we've got 2 side lengths that are given here. I've got side AC, which equals 10, and I have side AB, which equals 12. I can see that 12 is the larger number, so I know that side AB is greater than side AC, because 12 is bigger than 10. And if it helps you to see the numbers, you can write them in here. So now, to figure out which angle is larger, I'm going to look at the angle that's straight across from each of the sides. So the angle that is across from side length 10, which is AC, I can see that that's going to be angle B. And the angle that's across from the 12 is going to be angle C. And since 12 is larger than 10, that tells me angle C is the larger of the 2 angles. So the bigger angle is always across from the bigger side. That's what this theorem states. Next theorem, again, don't memorize the number. This one is called the triangle larger angle theorem. And this one states if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So again, I'm going to compare. I'm going to look to see which is my bigger angle. So I've got 60 degrees here. So angle C, the measure of angle C is 60. And then I can see that the measure of angle A is 30. And I can see that since 60 is a bigger angle than 30, I can state that angle C is larger than angle A. And then again, I'm going to look for the side across. So since the side across from the 60 degrees is going to be side AB, I could say that AB is greater than the side across from the 30, which is going to be BC. So again, you're going to look for the side across from the angle measure to determine the biggest side. Now, I'm going to give you a little variation on this. Now, if you're asked to just compare the sides based on the 2 angles in the picture, this is what we would do. However, when you're doing the homework tonight, I'm going to ask you to find the largest side of the triangle or the smallest side. And in order to do that, we're going to have to find the missing angle first. So let's go ahead, and I'm going to modify this theorem here a little bit, or the example. So let me go ahead and redraw that same triangle. And remember, these figures are never drawn to scale. So if I draw this, if I put in the numbers here, and I add in the 60 degrees and the 30 degrees, remember, we can use our triangle sum theorem that states that the 3 angles of a triangle always will add up to be 180. I'm going to take the two angles that I already have, the 60 and the 30. I'm going to add them, and that gives me 90. I'm going to subtract that sum, and that tells me left over for angle B is going to be 90 degrees. Obviously, this picture does not look like that's a 90-degree angle, but again, you just got to use the theorems and the math behind it. So now that I filled in all three angles, now if I ask you to name the largest side or the longest side, we're going to look for the biggest angle, and the longest side of this triangle is going to be the side that is across from the biggest angle. And I could say that AC is the longest side.
Where are we?
I'm sorry?
Where are we?
Now, if it asked you to find the smallest side of the triangle, we would look for the smallest angle, and the smallest or the shortest side would be BC. If they ask you to order them from greatest to least, you could say that it goes from AC, then the next largest side would be AB, and then the smallest side would be the BC. And you might add inequalities in there. So just be able to order them least to greatest, find the longest, find the shortest, but always look for that missing angle first when you're comparing side lengths. We have one more theorem to cover. Okay, the next one, again, don't memorize the number. We're going to memorize the name, the triangle inequality theorem. And this one states that the sum of the lengths of any two sides of a triangle is always going to be greater than the length of the third side. So for example, in this picture, if I add side BC and I add that to AC, it needs to be greater than the third side, which is AB. And if I do the next one, taking them two at a time, this time if I add AB and add that to AC, it needs to be greater than BC. Now again, remember, you can also reverse the letters on these. Remember, when you're naming a segment, the order of the letters doesn't matter. And then the last one, if I add AB to BC, it needs to be greater than AC. Or we can say CA. So for example, let's say I gave you a picture of a triangle. ACB, and let's say I added some numbers here, and let's say this is 7 and 6 and 3. So what this means is if the shortcut way to do this is always just to take the two smaller numbers that are given to you, and if you add them, that third side has to be less than that. When it's going to ask you to give the range of numbers, what you're also going to do is take the two smaller numbers and also subtract them. And this third side, this red one, should be a number that's in between the sum and the difference. Has to be in between 3 and 9, which it is. So this would have been 3 good numbers that would form a triangle. And we're going to see this coming up in an example. So they're going to ask us to check to see if the 3 numbers will form a triangle. Technically, you can plug it into all 3 inequalities, but the shortcut is always to take the smaller sides. So you're going to take the 2 smaller sides, you're going to add them, and you're going to subtract them. If the third number is in between the sum and the difference, then you know it's a good 3 set of numbers to form a triangle. If it's too small or too big, or if it equals one of those, then it won't form a triangle. So the first example, it wants me to name the largest angle in this picture and the smallest angle. So in order to name the largest angle, I need to look for the largest side. And I can see that the largest side is going to be the 10. And then the angle across from that 10 is going to be angle C. To find the smallest angle, I need to find the smallest side, and that's going to be the 6. And then the angle across from the 6 will be angle B. So the next example wants me to find the longest and the shortest side. However, before I can do that, I need to find angle T, because angle T may end up being the shortest or the smallest or the largest angle. So let's go ahead and find angle T first. I'm going to use my triangle sum. So I'm going to add up 46 plus 105. I get 151. I need to subtract that from the total sum, which should be 180. And my missing angle is going to be 29 degrees. That made a difference in my answer because angle T is now the smallest angle in my triangle. So that's going to help me find the shortest side. But let's go ahead and do the longest first. So my longest side is always going to be opposite the largest angle, and my largest angle here is the 105. So my longest side is going to be, you can either name it as IT or TI. Either way, because it's opposite the largest angle, which is angle J. Now I'm going to look for the smallest angle, which is actually the one I just calculated. Angle T is the smallest angle. So the side across from that is going to be IJ. So the shortest side, IJ, or you could call it JI, because it's opposite angle T, which is the smallest angle. 2. So it wants me to fill in those blank lines with either a greater than symbol, a less than, or an equal to. So let me go ahead and give myself a picture because they did not draw this right triangle for me. So let me go ahead and draw a triangle ABC here. And it said it's a right triangle. And it also told me the right angle is located at angle C. Doesn't matter where I place A and B. Now, if you recall back, when we learned that triangle sum theorem, we also learned a corollary to it. And we also learned that the two acute angles of a right triangle are always going to be complementary. So that tells me that if the three angles of the triangle equal 180 and I subtract out the right one, that's going to leave me 90 degrees to share between A and B. A and B are both going to be acute. So angle A plus angle B is always going to equal 90 degrees because they're complements. All right, so now I don't even need to know the measures of A and B to answer these questions. All I need to know is C is the biggest angle. So because C is the largest angle because it's 90 degrees, then the side across from that is going to be the largest one. And that's what's going to enable me to answer part C here, that AB is going to be bigger than AC. So AC is less than AB. And again, it might have also been presented as CA and BA here. Now, since angle C has got the right angle, it's definitely larger than the acute angle A. So this one will get a greater than symbol. And then I just showed you here that A plus B equals 90. And if they told us at the beginning that angle C was 90, these are equal. So here it says the lengths of two sides of the triangle are 8 and 13. And then it says, then the lengths of the third side must be greater than what, but less than what. And again, this is where we are going to find the sum and the difference of these two numbers. So I'm going to add 8 and 13, and I'm going to subtract 13 and 8. This will give me 21. The difference is 5. So we're going to use that triangle inequality, and we're going to state that the third side must be greater than the difference and less than the sum. So what I'm going to fill in here, it's got to be greater than the difference, and the difference was 5, but less than the sum, which was 21. It cannot equal a sum or a difference. It has to be any number in between 5 and 21. And that would be an acceptable measure for that third side. So the third side could be 6. It could even be 5.5. Any number that's greater than 5 but less than 21. You can have fractions for your side lengths. Last slide. It says, is it possible for a triangle to have sides with the lengths indicated? Now, you could do all three inequalities, taking all the different combinations, but the easiest way to check it is always take the two smaller sides and add and subtract them. And if that third number is in between that sum and difference, then the answer here is yes. So I'm going to take the two smaller numbers. I'm going to take 6 and 8. I am going to add them, and I'm going to subtract them. I get 14 and 2. And because the third side, 10, is a number in between 2 and 14, yes, these three numbers will form a triangle. Let's try the next three. Again, I'm going to take the two smaller ones. I'm going to add them. I'm going to subtract them. If the third side, the 8, if it's in between 1 and 7, the answer is yes, but it is not. It's too big, so this answer is no. These three numbers would not form a triangle. There would be a little gap. There's no way you could connect them. I'm going to do the next ones. Again, take the two smaller numbers. If they're not presented least to greatest, look for them. Look through the three numbers and find the two smaller ones. So I'm going to add 2.5 and 4.1. I'm also going to subtract them. So the sum is going to be 6.6, and the difference is going to be 1.6. Because 5.0 is in between 1.6 and 6.6, this answer is yes. And then the next one, notice it's not presented least to greatest. So I got to look for the two smaller ones. So 2 and 4 are the two smaller sides. And then the 6 is the larger. So again, I'm going to add 4 and 2 and subtract 4 and 2. Notice my third side is 6, which was the sum. It cannot equal the sum or the difference. So this answer is no. It cannot equal one of those. And then the last example, again, notice two of the sides are the same. So I'm just going to take 6 and 5. One of the 6s to be the one that I add, and then the other 6 I'm going to say is the largest. So I'm going to add them. 6 plus 5, 6 minus 5. 6 plus 5 is 11. 6 minus 5 is 1. And because 6 is in between 1 and 11, this will form a triangle, and it's yes. So that is it for your notes on 6.5.